warahmatullahi wabarakatuh. We are from Group 1. We will present the result of our discussion, which is about our review of 3 journals in chemistry education. Before we start our presentation, allow me to introduce our teammates. The first one, myself, Sarah Madila, and then Steffi Ariwibowo, Siti Humairo, Veronica Luciana, and Fitri Purnamasari. We have reviewed 3 journals. First, Developing Innovative Chemistry Laboratory Workbook integrated with Project-Based Learning and Character-Based Chemistry. Second, the influence of teaching models to provide concept change and project-based learning assisted mind mapping media with creative thinking about student learning results in Colloid system material of class 11. And last journal is project-based learning integrated to STEM to enhance elementary school student scientific literacy. So, allow me to explain the first journal. The first journal is Developing Innovative Chemistry Laboratory Workbook integrated with Project-Based Learning and Character-Based Chemistry. Authors' names are Bajoka Nainggolan, Wesley Huta Barat, Manihar Situmorang, and Marham Sitorus. The journal name is International Journal of Interaction, published in 2020. The reason why we choose this journal is because it contains how to produce an innovative chemistry laboratory workbook or InnoChemLaw, followed by the implementation of the learning package in the teaching of the chemistry. Next, the abstract or the purpose of the journal. The research was carried through research and development to produce an innovative chemistry laboratory workbook, followed by the implementation of the learning package in the teaching of chemistry. The research showed that a standard InnoChemLaw has successfully been developed on the topic of colligative properties of solution. An InnoChemLaw package helps the student to learn chemistry independently, so that the learning stages are carried systematically. The students are actively completed the project, thereby increasing their knowledge and skills. The keywords of the journal: character-based chemistry, chemistry innovation, colligative properties, laboratory workbook, and project-based learning. Next, introduction and methods. Introduction. The introduction contains information about how innovative chemistry laboratory workbook learning integrated with project package that are packaged with computers is very appropriate to motivate students to learn independently in increasing their knowledge and skills in chemistry. Method that used in the journal is research and development. The research procedure consists of syllabus analysis, chemistry laboratory workbook analysis, design and development of the workbook, implementation, evaluation, and data analysis.
The result and discussion. The result of the analysis of the contents of chemical material, language, and presentation are summarized in Table 1. You can see Table 1 on the screen. Table 1 assessment result from expert respondents on the feasibility on the InnoChemLaw package that are selected from various publishers. And then marking criteria: 4 equals very good, 3 equals good, 2 equals poor, and 1 equals very poor. Teaching material of an innovative chemistry laboratory workbook has been standardized using experts, namely chemistry lecturers and experienced chemistry teacher, and respondents' response to the feasibility of an InnoChemLaw are summarized in Table 2. Table 2 you can see on this screen. Result of expert judgment lecturers and teachers to the feasibility of a developed InnoChemLaw based on the BSNP indicators, and then marking criteria. 4 equals very good, 3 equals good, 2 equals poor, and 1 equals very poor. From this result, it is known that an InnoChem W package have met the requirements to be used as a sport chemistry material in learning activities in teaching of colligative properties of solution. All chemistry teacher and teacher respondents gave positive response to the feasibility of innovative teaching materials so that the developed innovative learning package could be implemented in learning chemistry. And then table 3 you can see on this screen. Student performs based on learning achievement and the character chemistry skill. Study chemistry by using the developed InnoChem W aims to improve student learning independence by doing the chemistry projects guided by an innovative learning package so that students have the ability to conduct chemical experiments correctly. The student performs based on character chemistry skill. Psychomotor assessment rubric has been observed as summarized in table 3. The results show that student psychomotor skill in the experimental group includes 86.86 more or less 5.96, were found higher when compared to the skill obtained by the control group. M includes 78.5 more or less 5.5, and two groups were significantly different, 3.156 greater than the table 1.678. It can be stated that learning chemistry by using InnoChem W can improve student knowledge and psychomotor simultaneously. I need analysis to the existing chemistry laboratory workbook has been carried out as basis to build an innovative chemistry laboratory workbook so that it meets the needs and feasibility as a learning package to be used to learn the chemistry topic of colligative properties of solution. All witnesses found in InnoChem W are correct through innovation by adding project and proper character-based chemistry suite to high school students. A conclusion. According to the result, we can conclude that innovative chemistry laboratory workbook for the topic of colligative properties of solution has been developed through the needs analysis step following the demand of the national curriculums. The InnoChem W package is equipped with project and character-based chemistry that can build student ability in the investigation and integrates with computer technology to make it simple to encourage students to study independently. Experts standardization showed that the InnoCam LW package has fulfilled the BSNP requirement for secondary school. Implementation of the InnoCam LW increased student performance where students performs in cognitive and psychomotor skill. In the experimental group were found higher than the control group. It was science to innovative workbook integrated with computer and based on the BSNP indicator. Met IR 4.0. Therefore, teacher and student integrate with other using internet during teaching and learning process. In other words, university and higher education have to find solutions to the new and innovative computer technology developments. F. Suggestion that we can give to the other, or we hope that they can make it more structured so reader easily understand the points. Strength and weakness. Strength. The journal provides innovative learning methods that are very relevant and needed. And then the journal presents a card that makes it easier for readers to understand its structure. Weakness. The words or sentence that others use too hard to understood.
Okay, next the second journal. The influence of teaching models to provide concept chain, M3PK, and project-based learning, PGBL, assist mind mapping media with creative thinking about student learning result in college system, material of class 11 men. Authors Rizky Wardani Daulay, Simpson Tarigan, and Iis Siti Jahro. Journal name Journal of Research and Method in Education, published years 2017. Purpose of journal to produce how to determine 1. Differences in student learning outcomes M3PK with PJBL using mind mapping media. 2. Differences in student learning outcomes that have high creative thinking ability with low creative thinking ability. 3. The interaction between M3PK and PGBL uses mind mapping media with students' creative thinking ability in influencing learning outcomes with creative thinking about student learning result in college system, material of class 11 men. Abstract. This study aims to determine 1. Differences in student learning outcomes M3PK with PJBL using mind mapping media. 2. Differences in student learning outcomes that have high creative thinking ability with low creative thinking ability. 3. The interaction between M3PK and PJBL uses mind mapping media with student creative thinking ability in influencing learning outcomes. Keywords: Teaching model induces chain of concept, project-based learning, mind mapping, learning outcomes, and creative thinking ability. Next, introduction and methods. Introduction. The introduction contains information about how to examine the influence of teaching models to induce conceptual changes and project-based learning using mind mapping media with creative thinking ability to student learning outcomes. Methods. The research was carried include quasi-experiment research, which was given the treatment of learning by grouping the research sample into two groups, with each variable that is M3PK and PGBL. The research procedures consist of data collection are preparing the instrument, determining the sample, preparing the syllabus and lesson plans, learning media, implementing the prints, doing the learning according to the design, and implementing the post-test.
Result and discussion. The learning in experimental class 1 that was taught by the mind modeling teaching model M3PK with mind mapping media saw the maximum result of learning compared to the experimental class 2 that was taught by project-based learning, which was accompanied by mind mapping media in table 2. Comparison diagram of post value in experiment class 1 M3PK with mind mapping media and experiment class 2 PGBL with mind mapping media can be seen in figure 1. Data of student creative thinking ability is obtained by observation to student during the learning process take place. The data of student creative thinking ability is described in the table. The result of the first study showed that the use of effective M3PK learning model to improve student learning outcomes. The result of the second study general showed the learning model significantly affect the student creative thinking ability with the significant value. Price significant 0 means that the learning model influence student creative thinking ability on the subject of the colloidal system. The third research result showed that is interaction between learning model using mind mapping media with student creative thinking ability to influence learning results. Based on data processing and discussion of research results that have been done, can be drawn conclusion as follows. 1. There are significant differences in learning M3PK and PGBL with mind mapping media assist on student learning outcomes. There are differences in student learning outcomes that have high creative thinking ability with low creative thinking ability. There is an interaction between the learning model with student creative thinking ability in influencing the learning outcomes. Suggestion that we can give to the author that the delivery is simpler so that it makes it easier for reader to understand from the journal they read. Strength and weakness. The journal provides method how to creative thinking about students so that there is the interaction between the learning model with student creative thinking ability in influencing the learning outcomes. The journal presents a chart that makes it easier for reader to understand its structure. Weakness. The word or syntax that the author used shall be simple but include everything that is explained.
Hello guys, my name is Stevi Aribowo. I'm from Group 1. In here, I will continue to explain the third journal. The third, project-based learning integrated to STEAM to enhance elementary school student scientific literacy. The author is J. Afriana, A. Permanasari, and A. Fitriani. Journal name Science Education Study. Published years 2016. The purpose of journal. The reason why we choose this journal because it contains how to depict project-based learning, integrate with science, technology, engineering, and mathematics, STEAM, to enhance elementary school student science literacy. The study was done to define project-based learning, integrate with science, technology, engineering, and mathematics. To enhance elementary school student science literacy, the used in this study was air pollution. Research method was quasi experimental with the matching only pre-test, post-test control group design. Okay, the next is introduction and methods. The introduction. The essence of science learning is not only to remember and understand concepts found by scientists. Modern science learning gives direct and meaningful learning experience which can be applied in the daily activities. The meaning science learning can be acquired through student science literacy, which is beneficial in problem-solving activity. The method is the study was done by quasi experimental method with the matching only pre-test, post-test control group design. Class matching in this research was assumed as a class which had equal ability and taught by the same teacher. This experiment was done by conducting learning in PGBL STEM model in experimental class and common use learning in control class. Result and discussion. The result of the analysis of the table 2 show that there is a differences between student scientific attitude achievement in experimental and control class. The highest achievement in pre-test, post-test, gain and end gain was in experimental class and the lowest was in control class. Table 3 describes that the significant value acquired from studying and gain scientific literacy data of experimental and control class in experimental and control class in aspect of knowledge and the scientific competence are smaller, saying equal p-value 2 equal 0.0532 equal 0.026 from alpha sin 0.026 less alpha 0.05, so H0 is rejected and H1 is accepted. Learning model in both class is assumed can enhance student scientific literacy, where PGBL STEAM was implemented in experimental class and CTL in control class. Research of Duiters and Power 2006 revealed that PGBL can enhance scientific literacy by active involvement of K-12 students as well as student interest and competence in STEAM concepts, while CTL approach with its 7 stage apply in science learning can build student scientific literacy. Figure 2 describes the rest of STEAM except combined with student scientific literacy question. Experimental class was superior in indicator of S, ST, and STE, while control class was superior in SM indicator. It showed that science learning generally had combined mathematics in doing calculation as well as associating experimental data. Conclusion: project-based learning integrated with STEAM in experimental class was significantly enhanced student scientific literacy skill in air pollution concept. The rise based on N-gain average score for experimental class and control class were respectively 0.31 and 0.2 aspect of knowledge, competence, and scientific attitude in experimental class was in medium category and control class was in low category. The rest of scientific literacy, which accommodated by STEAM aspect in experimental class, is superior in indicator of science, science technology, and science technology engineering STE, while control class was superior in science mathematics indicator. The suggestion that we can give to the author are: we hope that they can make it more structured so reader easily understand the point. Strength and weakness. The strength: the journal provides project-based learning integrated with STEAM in experimental class was significantly enhanced student scientific literacy skill. The journal presents a chart that makes it easier for reader to understand its structure. The weakness: the word of sentence that author used too hard to understood. Okay guys, thank you.